welcome and good morning in the next lecture of the radar and TV engineering. Today we will discuss about the CCTV or CCD cameras and picture tubes. In last lecture, we have already discussed about the TV transmitter and the TV receiver system. In the TV transmitter section, we have already discussed the each section of transmission system or fundamental of the TV transmitters. And in the next section, we have discussed the receiver section. In the receiver section, we have discussed about all the type of blocks of receiver system, all in component of the receiver system. Now we have the main part of the TV system is the camera tubes. In previous lecture, we have already discussed the types of the camera tubes and picture tubes. Now we will discuss today CCD cameras and picture tubes. So cameras is used in to capture the pictures, and the picture tubes are used at the receiver sections. The content of this video lecture is the CCD camera, picture tube, types of the picture tube, construction, working principle of the picture tube. The main objective of this video lecture is to understand the basic fundamental of the camera tubes, to understand the basic concept of the picture tubes. Students will also learn about the working of the picture tube. They will also learn the concept of the picture tube and camera tube, working, construction, and types of the camera tube and picture tubes. The outcome of this video lecture, student will understand the concept of CCD camera. They will also learn the picture tube. Student will also learn the picture tubes with the types of the picture tube and advantages and disadvantages. The textbook for the radar and TV engineering, to understand the TV engineering is the second part of our syllabus, that is the monochrome and the color television, second edition by R.R. Gulati. Other reference books is given for TV engineering. Now we come to the main part or main things of TV transmitter, that is the camera. The main part of the CCD camera is the CCD image sensors. This type of the image sensor, it sends the image. CCD consists of very closely packed MOS capacitors formed by the P substrate SiO2 and the metal gate, which can store or transfer the analog charge signals. The CCD is composed of precisely positioned light sensitive semiconductor elements arranged as row and columns. Each row in the array represents a single line in the resulting image. This is the diagram for the CCD camera. This is shown the how the charge is moved from the plus V to lower, and the working of this CCD is the application positive potential to the gate. Result development of the depletion region just below them. When we apply the positive voltage to the gate, so there is the depletion region is formed, potential valve just below them. When any image is focused onto the silicon chip, electrons are generated within it. The number of the electrons depend on the intensity of incident light, and hence depth varies according to the applied voltage. The number of the electron depends on the uh, intensity of the incident light, and hence the depth varies according to the applied voltage. Once reduced, they collect in the nearby potential wells. The charge of the one element is transferred to the next element by applying a higher voltage to the next gate and reducing the voltage of the gate. The gate electrodes operate in group of three. For good resolution, we assign a three capacitor pixels. The charge transfer is carried by the multi-phase clock applied to the gates. After one complete clock cycle, the charge pattern moves from one stage to the next as an analog shift register. CCD camera, the sensors and vertical shift register, horizontal shift register, output. This is the image of CCD cameras, and that sensors are arranged with the vertical shift registers. Sensors are connected with the shift register, and horizontal shift registers is connected with the vertical shift register. Scanning steps into the two integrate period. One set of the electrode is supplied with the constant voltage, creating a deflection vision. Duration 1 to 10 seconds. Without period, phase clock pulse applied to the transfer stored charge to storage section. Duration is 100 microseconds. CCD sensors fabrication method. The frame storage transfer mode, interline charge transfer mode, and frame interline charge transfer mode. So here the how the sensor sends the image and they convert it into the output of camera is given by this image. So this is the photo sensors, vertical shift registers, and we have the horizontal shift registers and the amplifiers. The photo sensor sends the image, and the image is given to the vertical shift registers. Correspondingly, we have a horizontal shift registers and amplifier. So output of the shift registers is given to the horizontal shift registers, and it is goes to amplified. So finally, we get the amplified output of the CCD sensors or CCD cameras. So image is converted into the electrical signal. Here, the picture shows that the yellow light is illuminated, and step by step it is goes to the electrical signal. How the process is followed is given by this picture. So through this system, we are able to understand that the image is converted into the picture, electrical signal, or any photo is converted into the electrical signal by the CCD camera. The CCD image scanner consists of a large number of CCD devices arranged in the rows and columns to form an image area. Individual lines are addressed sequentially using an address register. The output circuit will contain the electrical representation of the picture information. It does not need an electron gun beam, high voltage, or vacuum envelope of conventional camera. For interlaced scanning in cameras, the charge transfer to the vertical shift register is accomplished in two stages. The odd number rows followed by the even rows. Next, the charges in the vertical register are shifted into the horizontal shift register and clocked to the CCD output. All the odd rows are clocked out first or filled, followed by all the even rows even filled. The rate at which the charge from the horizontal shift register is clocked out is governed by the number of the element pixels per row and video standard the camera complies with. Advantages: the CCD camera is the high sensitivity, image lag absent, means lagging of the image is absent in this because it has high sensitive type of the camera. The spectral response is very good. Sensor withstand excessive illuminations. No geometrical distortion or non-linearities. Lightweight and low power. Limitations: requires the external processing unit, relatively high power consumption, expensive. So these are the some limitations for the CCD cameras for image scanning that requires the external processing unit, uh, high power consumption, and the extensively expensive. The main application of CCD camera, it is used in the barcode scanners. It is used in the scanning of barcode at the malls, at the shopkeepers, or in the library. Camcorders, it is used as a camcorder to convert the image into the code form, and fax machine. It is used in the fax machine also. So these are the application area of our CCD cameras or CCD camera. Video processing of the camera pickup signal. How the video is processed by camera pickup signal. The optical image is focused by the lens on the glass face of target plate. The lens regulates the light by the iris built into the lens housing. The output of video signal is taken across the load register. So this is the image, how the video signal image is processed and converted into the video signal by CCD or any type of the camera tubes. So light is come from the scene and lens is converted into the parallel wavefront into the wavefront of electron beams, and it is given to the camera tubes. So camera tube is having a anode and cathodes, and electron beam is passed through this. Electron beam is focused on that anode, and we have a signal which is applied to the preamplifiers, which is amplify the signal level, and signal processor unit is there to process the signal, and sync added here. The synchronizing pulses is added, and correspondingly we get the video signal output. So video signal output combine the composite signal, that is the blanking pulse and the sync pulse and the video signal. So this is the electron beam scanning in the camera tubes. We have already discussed how the scanning of the electron beam is occur in the image processing unit or image sections. Amplify the weak low voltage signal from the load resistance RL, addition of the blanking pulses, addition of sync pulses. So in the amplify section, after amplification, we add the blanking pulse and the sync pulse in the corresponding video signal. The signal current or voltage across the load resistance RL. So if P amplifier is used at the first stage, the output terminal of camera tube to avoid external interference. The second stage, we are using the signal processors to add a blanking rise during the horizontal and the vertical trace interval. Sync adder circuit is used to add the synchronizing pulses. The output waveform has a voltage of about IV peak to peak voltage, that is across 75 ohms as shown. That is shown in the figure, that is the 75 peak to peak, 75%. That is be located at some distance from the camera. A principle of the working and block diagram of color TV camera. Now we have a TV camera. The construction, working, and all things are same as CCD camera. So before going to start the particular camera, we'll learn about the fundamental of the color TV cameras. A color camera tube is used to split the optical image into the primary colors. Means any optical image is converted into the primary colors. The special type of the mirror called dichroic mirror is used to split the image into the colors. So there is a camera dichromic mirror, and the light from the picture and lens assembly. This assembly, color conversion, and natural density filters. Then we have a dichromic mirrors, and this mirror is converted the image or picture signal into the, or light from the picture is converted into the three output, that is the red cameras, that is the VR, green camera, VG, blue camera, VB. So red, green, blue, these three voltages developed through the three mirrors. That is the red dichromic mirror reflect the red colors and allow other color to pass through it. The scene is the focused by the zoom lens package on the dichromic mirror setup, and they are passed through the color filters. These filters can provide the precise primary color images. Each camera tube develops video signal voltage proportional to the color intensity received by it. A video preamplifier amplifies the VR, VD, VG. 50 voltage signal. In the output stage, a resistance network is used to generate the luminous signal and color signal. So resistance value are so related such that the luminous signal Y equal to the 0.3 R plus 0.59 G plus 0.11 B. If only red color light is focused, then we have only the red camera output VR. Then Y equal to the 30 upon 30 plus 70, that is VR equal to the zero point 0.3 VR. So this is the equation or the value of prominence signal. Picture tubes. In the next section, we have a picture tubes. So camera tube is a tube or device which convert the image or the light signal into the composite video signal. And picture tube is a device or tube as a CRT which develop the picture at the screen through the electrical or video signal. The size of the picture tube is generally denotes the diagonal length. The size of the picture tube ranges from 1 inches, that is to 30 inches or more. So 30 inch equal to the 76 centimeter, because the 1 inch is correspondingly completely 2.5 centimeter, equivalent to 2.5 centimeter. And so we have a picture tubes of 1 inches to the 30 inches or more than 30 inches available nowadays. Most of the commonly used tubes in the black and white TV and the color TV are 51 centimeters and 36 centimeters screen size. And this size is measured in the diagonals always. So black and white TV is available into 51 centimeters, and the our color television is available in 36 centimeters. The tube example is the tube 500 AMP4 has the diagonal length 500 millimeters, that is 20 inch. The last alphabet P specify the screen is the phosphorus screen. Another monochrome picture tube specification is given here, that the commonly used picture tubes manufactured in India and marketed by the BEL, that is Bharat Electronics Limited, are 310 C1P4, 470 C1P4, 610 C1P4, 590 C1P4 picture tubes employs the electrostatic focusing and electromagnetic deflection. So these monochrome pictures tubes are based on the electrostatic focusing and electromagnetic deflections. Now we have the constructions and working principles of monochrome picture tube. The picture tube is used to convert the video signal into the optical signals. We have already discussed that picture tubes are monochrome and color television picture tube, which is used to convert the received video signal into the optical signal. But a camera tube is convert the optical signal into the video signal. This is the difference between the picture tubes and the camera tubes. Now construction. In the construction, we have the main part of the monochrome picture tubes, that is electronic guns, focusing anodes, deflection coils, final anode, phosphorus screen, external conductive coating. So this is the image of picture tube, that is the monochrome type picture tube. And in this picture too, we have a cathode and anode. The base cathode will generate the electron beams, and it is focusing by electrostatic focusing, and some deflection coil is available for deflections, and this arrangement is into the glass envelopes. The cathode will generate the electron guns and electron beams, and this beam is uh, arrived at the phosphorus coating of screen. So inside of the screen we have a aluminized coating, and in between of the glass and aluminized coating we have a phosphorus coating. This is the important coating to display the pictures. And inner of the this tube we have an inner inductive conducting coating, aqueduct conduction coating. So we have a G1 and G2 and G3 is the control grids, accelerating anode, focusing anode, correspondingly respectively center magnetic and error magnets. We have here the EHT is equal to the 18 kilovolt, and some deflection coil arrangement is also in this picture. So this is the basic architecture of the picture tube for monochrome color television system. Now we will discuss the one by one part of picture tube. The electron gun unit consists of cathode, control grid, and accelerating anode. It is indirectly heated by a filament. Thorium, tungsten, or borium and strontium oxides are having low work function and so release a sufficient number of electrons of when heated. So in the electron guns, the electrons is generated by the filament. So cathode will generate and control the electron gun. The control grid is used to control the flow of the electron from the cathode. It is also in the form of cylinder and for flow of electrons. Screen grid is maintained at 400 volts and focusing grid is maintained at 600 volts. Through this base pin, only the rated voltage for different grids are supplied. Electrostatic method is used to focus the electron beam. The positive potential at the accelerating anode is extended. This is considered as first lens action. Screen grid and focus grid forms the second lens system. The focus anode is larger in the diameter and also its potential is higher than the first anode. The voltages given to the grid are so selected that the second convergence point is on the screen picture tube. Deflection coils. Electromagnetic system is used to deflect the electron beams in the horizontal and the vertical direction. So the deflection coils is available here to deflect the electron beam in the horizontal and vertical directions. A picture tube produces the horizontal deflection, and another pair of the coil placed left and right produce the vertical deflection. The two pair of the coils are collectively called deflection yoke. The deflection yoke, centering magnet and pin torsions magnet are also provided for centering electron beams. So this type of the deflection yoke maintain the electron being in the center of the picture tube at the moment of electron beams at corners. Final anodes to provide the sufficient velocity and energy for electron beam, a final anode is included in the tube. This aqueduct coating is provided with a high voltage of 10 kilovolt or more. The secondary electrons emitted from the screen are attracted by these coating. Phosphorus aqueduct screen. The phosphoric chemicals are light metals such as the zinc, cadmium in the form of sulfate, sulfide, and phosphate compounds. The atoms, while hitting the coating, hitting spot fluorescence emit light. External conducting coating. Aqueduct is also coated on the outer surface of glass bell. A spring clip used to connect this coating with the chassis ground AC ripples in the high voltage and provide a perfect higher voltage. Now the working principle of our picture tubes, how the picture tubes are worked. An AC supply of 6.3 volt is given to the heater filament. This filament heats cathode and cathode emits the electron beams. The number of the electrons in the beam is controlled. The accelerating anode increase the velocity of moving electrons. A point and good morning and welcome in the next lecture of the electromagnetic field theory. In this subject, we are studying about the electromagnetic field theory. In previous lecture, we have discussed about the electric fields, electric field lines, Coulomb's law, Gauss law, electric flux density, and we have also discussed the vector calculus, dot product, cross product, and coordinate systems. We have discussed the three types of the coordinate system in the electromagnetic field theory to understand the electromagnetic field concept. First is the rectangular coordinate system, that is known as Cartesian coordinate system. Second is cylindrical coordinate system, which is known as circular system, and last is the spherical system, which is applicable for sphere. So up to this, we have cleared the relationship of the electric field intensity and the charge, how the charge is develop the electric field or electric potential. Now today we are going to discuss about the electric dipole, electric potential, energy, work due to the electric field. And in the last we have here to discuss the conductor, semiconductor, and insulators. The main content of this video lecture is the electric dipole, electric potential, work, energy, conductor, and semiconductor. These are the main content of this video lecture. Today we are going to discuss these topics. Now, prerequisites to learn this lecture, to understand this lecture, the student is required to learn the vector calculus, calculus, Coulomb's law, vector form of the Coulomb's law, electric field intensity. They are also able to understand the electric flux and Gauss law, electric flux density. These are the main prerequisites for understanding of the electric fields or dipole in conductor, semiconductor, and insulators. The course is focused on the foundation of electromagnetic field theory. In this lecture, student will learn the electric dipole and conductor, semiconductor, and insulator theory. The basic learning objective of this video lecture is that a student will able to understand the concept of electric dipole, electric potential, energy, and work in the field of electrostatics, the conductor, semiconductor, and insulator. Student will understand the concept of the conductors, semiconductors, and insulators. They will differentiate the three types of the materials. These are the textbook and other references which is used to learn the electric dipoles, conductor, semiconductor, and other field or other topics of electromagnetics. The Principle of the Electrostatics, fourth edition by Sadhu, is the very good book for beginners to understand the electrostatics theory. The main outcome of this video lecture is that the student will familiar with the electric dipole, concept of the electric potential, energy, and work in the case of electrostatics theory. They will also understand and learn the conductor, semiconductor, and insulators. They will learn the difference between the conductor, semiconductor, and insulator. They will understand the concept of these three materials. An electric dipole consists of 2-point charges of equal magnitude but of opposite sign and separated by a small distance. The electric dipole consists of 2-point charges. So the magnitude of these charges will be the same, but the sign is opposite. And these are the separated by a small distance. So the electric dipole is formed. As shown in the figure, the dipole is formed by the 2-point charges Q and minus Q. The magnitude of charges is same, but the sign of charges is opposite. Separated by the distance d, the charges being placed symmetrically about the origin. Let us consider a point P at a distance r where to find the field. See from the figure, as we have discussed, that a rod or a dipole has positive charge and negative charge at the end, and it is at the distance d, and it has a point P at the distance r, and r1 is the distance from the q, and r2 is the distance from the minus q, and the angle is formed by the z axis is theta. So this dipole is placed at the origin in the XY plane. Now we will calculate the potential at P point due to the dipole can be written as V is the electric potential 1 upon 4 pi epsilon naught Q upon R1 minus Q upon R2, which we have already discussed in the previous lecture about the electric potential or electric field voltage. So Q upon 4 pi epsilon naught into R2 minus R1 upon R1 R2. This is the potential at P point due to the R distance or R1 or R2 distance due to the Q and Q charges. So R2 minus R1 is equal to the 2d cos theta upon 2, or it will become d cos theta. From the trigonometry, we are able to calculate it is producing the theta angle with the z direction. So we able to calculate the point P and R2 minus R1, that is the R2 minus R1 is given by the 2 times of d cos theta upon 2. So R1 is equal to, nearly equal to the R2 is equal to R. Now we assume that R1 R2 is equal to the R. So B equal to the Q upon 4 pi epsilon d cos theta upon R square. So potential at the point P due to the dipole at R distance is written as Q upon 4 pi epsilon d cos theta R square. This is the potential. We can write further that Q d cos theta is equal to the Q d Az dot Ay. The quantity P equal to the Qd is called the dipole moment of electric dipole. Hence, the expression for the electric potential can now be written as V equal to the P A R upon 4 pi epsilon naught R square, where the P is the dipole moment. It may be noted that while the potential of an isolated charge varies with the distance as 1 upon R, that of an electric dipole varies as 1 upon R square with the distance. See from this equation, if the dipole is not centered at the origin, but dipole center lies at R, the expression for the potential can be written as P equal to the P, where P is the moment, electric moment, R minus R dash on 4 pi epsilon R minus R dash Q, if the dipole is not centered at the origin. The electric field for the dipole centered at the origin can be computed as equal to the minus del V is equal to del V upon del R AR plus 1 upon R del B del theta A theta, which is equal to the QD cos theta upon 2 pi epsilon naught R cube AR plus QD sin theta upon 4 pi epsilon naught R cube A theta. Now the equation will become QD upon 4 pi epsilon naught R cube 2 cos theta EY plus sin theta A theta. So E is equal to the P upon 4 pi epsilon naught R cube. So in the bracket 2 cos theta AY plus sin theta A theta. Here P is equal to the electric moment and it is given by the Q into D is the magnitude of the dipole moment. Once again, we note that electric field of electric dipole varies as 1 upon R cube, whereas that of a point charge varies as 1 upon R square. Now we have the work done by the electrostatic field or electric field. It is often useful to characterize any stream any system that can impose forces on an object by the work it does that to that object. Suppose a charge q1 is located near another charge q. The force acting on q causes the work to be done by displacing q at a distance dl. So dw is equal to the minus f dot dl, which is equal to q e dot dl. So work done is equal to the f dot dl and is equal to the, you know that f is the related with the electric field intensity and charge. So f is equal to the q dot e dot dl. So this is the work done in terms of the electric field and charge. The negative sign indicates that the work done by an external agent q1 thus the total work done or the potential energy required to move q a distance dl from A to B is W is equal to the minus q A to B E dot dl. So W is equal to the minus q, integrate from A to B E dot dl. This is equal to V E minus V A into Q. So work done and energy in the electrostatic field. To determine the energy present in an assembly of charges, we must first determine the amount of work necessary to assemble them. Suppose we position three charges Q1, Q2, and Q3 in an initial empty space. Initially, there is no work done to transfer the charge Q1 from infinity to our workspace because the space is the initially charged free with no electric field in the region. However, there is a field present from the Q1 when we move Q2 into the position. The work done by transferring the Q2 into the our work space is the product of the Q2 times the potential difference between the Q1 and Q2. The same is true as we position charge Q3 with respect to charge Q1 and Q2. Here the work done by charges Q1, Q2, Q3. The work done is the W1 plus W2, W3. W is equal to the 0 plus Q1 V21 plus Q3 V31 plus V32. If the charge was positioned in the reverse order, then work done is total work done by charge Q1 and Q2. Q3 is equal to the W1, W2, W3 is equal to 0 plus Q2 V23 plus Q3 V12 plus V13. Just by adding the all the works possibly performed obtained, that is the 2W is equal to the by adding of these two equations in the reverse order and in the forward order. So we will get that 2 of work W is equal to the 0 plus Q2 V23 plus Q3 in the bracket V12 plus V13 plus 0 plus Q1 V21 plus Q3 V31 plus V32. So this is the total work done. It is comes as Q1 V1 plus Q2 V2 plus Q3 V3. So W equal to the 1 upon 2. The summation from value K is vary from 1 to N 2K VK. So work done is the same as summation of the product charge and electric field intensity. So work done is the depend on electric field intensity. Therefore, one can write that the energy W present in an electrostatic field due to